Hello everyone. I am Chen Liang from East China Normal University in China. The research topic I am reporting to you today is design of comprehensive evaluation of computational thinking in graphical programming environment. I will report from the following aspects. First, as we know, under the background of information technology, data revolution, new requirements have been put forward for the cultivation of talents. Computational thinking, as a basic literacy other than reading, writing, and mathematics, has been gradually integrated into the school curriculum system by many countries. With the continuous advancement of this process, people have begun to realize that it's too late to cultivate computational thinking since college, and the main position of computational thinking education should be shifted to the K-12 stage. However, there is no commonly used computational thinking teaching effect evaluation tool in Chinese middle school programming classrooms. There are many evaluation methods that can be used for reference, but whether it is suitable for Chinese classrooms is still to be discussed, and more practical and applied research are needed to demonstrate. Therefore, this study will take the middle school students as the research object, analyze the characteristics and scope of application of different computational thinking evaluation methods based on China's and foreign computational thinking evaluation cases, and optimize and integrate the corresponding evaluation schemes and tools. Finally, design and develop a set comprehensive evaluation plan provides new ideas and new methods for computational thinking evaluation. Before we begin formal inquiry, we need to answer the two questions of how and what computational thinking is taught. At present, the teaching methods of computational thinking at the K-12 stage in China are mainly manifested in the following three forms. First, the programming teaching activities carried out with the information technology classroom. Second, the interdisciplinary teaching activities of computational thinking combined with STEAM education. Third, the teaching activities of computational thinking as an independent subject. Considering the actual situation in China, computational thinking teaching based on graphical programming courses is a major trend. This is why our research topic focuses on K-12 graphical programming teaching. Then came the evaluation contents of computational thinking. There were many detailed and operational CT definitions had been proposed. Meta's computational thinking framework, computational concepts, computational practice, and computational perspectives, which are in line with the objective of information technology courses in Chinese primary and secondary schools. Knowledge and skills, processes and methods, and emotional attitudes and values can correspond to each other. Therefore, we can think that the mixed three-dimensional framework of computational thinking can effectively characterize and evaluate the learning results of students in computational activities. As an answer to the what to evaluate in this research. Okay, now let's be clear about the goals of this research. In order to provide evaluation programs for computational thinking in Chinese primary and secondary schools, and to promote the development of K-12 computational thinking education, the main objectives of this research are evaluation and analysis of existing computational thinking evaluation methods, construct a comprehensive evaluation plan for computational thinking. The research method of this article is shown in figure. It is important to note that, in the third stage, combined with the actual situation of K-12 computational thinking education in China, we construct a localized and comprehensive evaluation plan of computational thinking. The core content of computational thinking education is actually to train and acquire methods, transmit and develop thinking, which is a dynamic process. In response to such characteristics, most computational thinking evaluation, research, and practice use situation-based, evidence-based, and data-based evaluation methods to conduct investigations and measurements. Through combing and analyzing the existing literature, the current main computational thinking evaluation methods can be classified into 5 categories. test question method, procedure analysis method, scale analysis method, graphic analysis method, and interview analysis method. The brief description and advantages and disadvantages of these two types of methods are shown in the table. For example, the test question method refers to a certain stage in the teaching process for students to solve and answer questions to complete test. Its greatest advantage lies in its convenience and timely feedback. The disadvantage is the design of test questions is a difficult point. The procedure analysis method takes the procedure completed by the students as the analysis object, examines the performance of the students in each module. This method relies on the support of specific analysis tools like Doctor, Scratch, Script, all of which have the advantage of automatic evaluation, improves the efficiency of evaluation greatly. But because the object of this automated method analysis is the final result of student learning, the information and changes in many processes cannot be recorded and evaluated. The other three methods also have their own advantages and disadvantages. The scale analysis method is convenient but subjective. The graphic analysis method and the interview analysis method are more complicated to use and require a lot of work. Based on the above analysis and summary of various existing computational thinking evaluation methods, combined with the teaching status of Scratch programming in China's junior high school programming classrooms, this research proposes a set of computational thinking evaluation plan with design and development program as the core. The basic structure of the plan is as follows. See table. In particular, evaluation based on program development is essentially a semi-open project development test, including designated development tasks. But the development process and final development results are open and free. There are complete four tasks. Explain the function of the selected project, that is, read the code and describe it. Find problems, fix errors, and debug the code. Optimize the project by adding functions. Describe how to expand the project and add more functional modules. These four tasks correspond to four aspects of computational practice. Dr. Get Scratch is a free and open web application that can help students analyze Scratch projects, give feedback, and help students improve their programming skills and develop computational thinking. The project scores provided by Dr. Get Scratch can urge students to improve their programming projects. Specific and clear scoring standards provide students with a path to improve their programming skills. The warning of bad programming habits will lay the foundation for students to become excellent programmers. The interview will be carried out as the final link of this computational thinking evaluation plan, with the project development plan method as the core. In order to discover more details of the changes in students' computational thinking, and to supplement the final evaluation, the specific topics and questions of the interview are as follows. The specific implementation process is divided into 7 steps. 1. The reader introduces the process. 2. Selects one item from 3 groups of different difficulty according to his programming level. 3. They start to fill in the answer sheet at the same time and revise and improve the project. 4. Provide necessary help, such as explaining the meaning of the questions and solving problems in the use of the software. 5. The tester completes the design plan and project modification, puts final work and the screenshot of the score of the work into a folder named class name, submits it to the computer of the reader, and submits the paper answer sheet. 6. The readers will rate the tester's test results according to the scoring criteria. The score of the paper answer sheet is the average of the 2 scorers, and the program score is derived from Dr. Get Scratch. After the 2 scores are weighted, the final score of the tester is obtained. 7. Structured interviews were conducted with the testers. and the testers were evaluated on the development of non-cognitive dimensions according to the interview results. First, the results of program development task. In the 4 tests in the answer sheet setting, each tester has a different score. For example, in the completion of the first task, explain the function of the selected project. That is, read the code and describe it. Tester is scored the highest, 5 points, because he answered at points when describing and understanding, with a clear level and describing his own feelings, reflects a good level of programming knowledge and skills. The lowest score is tester C. The main reason for the lower score is that the description is confusing and not accurate enough. Another example. The third task optimized the project by adding functions. The 3 testers completed well, and tester A got full marks. The main reason was that he used a flowchart when describing how to add functions, which showed good results, clear ideas, and used the most simple and effective method to achieve functions in the program. Second, the different versions of the project files submitted by the testers and the corresponding doctored and scratch score screenshots reflect the process of debugging and iteration. As shown in figure, the tester keeps iteratively modifying the project to get a higher score. According to the feedback from the score, the tester uses the template code module to develop the corresponding function. Finally, the results of the interview. There are some interesting conclusions. Software experience, questioning the concept. Tester has to dissatisfaction and suggestions for scratch software. First, if you add code and need to reset, it is better not to add the code. The object is in the initial state. And second, why can't the project be opened directly by double-clicking? It is recommended at this function. We verify the reliability and validity of the evaluation scheme. The Spearman correlation coefficient of the score is 0.943. The consistency of the score is high, which means that the reliability of the evaluation plan is high. Then evaluation program validity test. Based on the Delphi method discussion, experts believe that the evaluation program has a certain degree of validity. We verify the make a conclusion. Based on the test process and test results, the comprehensive evaluation scheme of computational thinking designed in this study is feasible and effective. In particular, the main advantages of the evaluation plan are 1. Effectively stimulate the enthusiasm of students. The contextualization of project creation can stimulate students' competitiveness, and the interestingness of the project will generate enthusiasm and interest in students. 2. The links are set reasonably, conform to the teaching arrangement. The entire mock exam is conducted in strict accordance with the implementation process of the evaluation plan, with reasonable time arrangement and low operational difficulty. But there are also some problems. The main problems of the evaluation program are such as the evaluation procedure is stricter. Students may have difficulty understanding the task. All in the follow-up research and study, the author will go deep into the frontline teaching practice classroom to collect data to further confirm the reliability and validity of the evaluation program. That's all. Thank you for listening.